Okay, we are going to be going through 6b, and 6b is focusing on learning to define sine, cosine, and tangent functions. So this is revision of about 3 exercises from Unit 1 and 2 methods. So be mindful, this is what you've already learned. It's just making sure you have that extra understanding of it so we can move on. So whenever we are thinking about a unit circle, we really need to be understanding it in terms of, oops, I'll get laser, in terms of our y value. And the y value we always focus on is sine, because our sine is opposite over hypotenuse. And if our hypotenuse is 1, it's our y value, which is what we've got here. So our sine will always be our y for our y point, and our cosine is adjacent over hypotenuse. That is our x value because we're talking about a unit circle here and we're dividing by 1. So that's what we've already learned. So that means this point here is going to turn into cosine for our x and sine theta for our y value. Now, if we are wanting to evaluate, we are just needing to be thinking about whereabouts is it on our unit circle. So sine, well, first pi is referring to this area here. So the position is -1, 0. Sine refers to the y. So the y value here is 0. So which means sine pi equals 0. For cosine pi, again, we know the position is over here at -1, 0. If we are thinking about cosine refers to the x value. So the x value here is -1, so cosine theta will be -1. If I continue, same thing here, where if we've got sine -3 pi over 2. Now, if I start here, we're really just going from 0 down because it's negative pi over 2, negative pi, and -3 pi over 2. That means we're up here. So that means my coordinate is x is 0, y is 1. From there, I'm talking about sine. Sine refers to the y. So sine -3 pi over 2 will be 1. If I look at cosine, -pi over 2. Again, I'm starting at 0. I'm going down to pi over 2. And that's negative, so that's why I've gone down. My coordinate point here is x is 0, y is -1. We know cosine refers to our x, which means our x value here is 0. So cosine -pi over 2 is equal to 0. If I look at the next one, which is sine -7 pi over 2. Now, this is slightly different. So first thing I always think about is how many 2 pi's are there in 7 pi over 2? So that is going to take, because it's over 2, will be 4 pi over 2, which is 2 pi. So I'll rewrite that, and that gets me back to here, and I'm just looking at this area here. So -3 pi over 2. I then continue until I get to -3 pi over 2. So we need to understand these points. We're talking about sine here. Sine at this point is x is 0, y is 1. Sine refers to the y, so then we know the y value here is 1. So sine -7 pi over 2 is equal to 1. Again, if I'm dealing with cosine, -5 pi over 2, I think of how many 2 pi's are in here. And then I can say, well, 4 pi over 2 is 2 pi. So what's left? An extra pi. So then I can rewrite it as -2 pi take away 5 over 2. So that means I go around once and that's negative 2 pi, and then I continue once more to negative pi over 2. I need to think about the coordinate. This is x is 0, y is negative 1. We know cosine is referring to the x because it's adjacent. So that means what is my x value here? The x value is 0. So now we can understand with splitting it. It doesn't matter what I give you. 69 pi, I just look at, okay, well, each time we go around, it's an even number, so 2, 4, 6. So what's the closest? 68. So it's 68 pi plus pi. That means I've gone around 68 pi times. An extra pi will land me over here, which is negative 1, 0. We're talking about sine. Sine is y value. So then here, the y value is 0. So sine 69 pi is equal to 0. Okay. This is the same thing that we will be doing with tangents. This is the second lesson that you would have covered now in Unit 1 and 2. So we know that if we're talking about tangent, tangent refers to opposite over adjacent. Our opposite here is our sine, and our adjacent here is our cosine. So that's why tangent theta is equal to sine theta over cosine theta. So we're just going to apply that. So if we're talking about to determine the values of sine theta, ignore that part, we're going to do tan 2 pi. That should be tan up here. So tan 2 pi, the first thing I need to think about is we said opposite over adjacent. Opposite is my sine, adjacent is my cosine. So I've got sine 2 pi over cosine 2 pi. So if I'm at this point, sine refers to my y value. My y value here is 0 because the point here is 1 and 0. Cosine is my x, and x refers to cosine refers to x, and my x is 1. So it's 0 over 1, which is 0. If I go to negative 3 pi over 2 for tan, same thing. That would have meant I started here. I've gone around to negative 3 pi over 2. But I do need to think about it as sine theta over cosine theta. Sine is y, or opposite, cosine is adjacent. I plug it in. That means I'm going, okay, what is my sine value right here? Sine is y. That means it is 1. What is my cosine here? Cosine is x. X is 0. So I've got 1 over 0, which is undefined. This moves on to a third lesson that we would have covered now in Unit 1 and 2. And this is about understanding the quadrats. So in quadrant 1, sine is our y, and y is positive. Our x value, which is our cosine, is positive. And if we do tangent, a positive divided by a positive, we get positive. That's why everything is positive here. If I move to quadrant 2, the y, which is our sine, is positive, cosine is negative, and for tangent, a positive divided by a negative is negative, which means it's the only thing that's positive here is sine. In quadrant 3, sine is y and it's negative. Cosine is x and that's negative. Negative divided by negative for tangent gives us a positive, so tangent is positive. Same with quadrant 4. Quadrant 4, x is positive and that is our cosine. Our y is negative and that is our sine. And negative divided by a positive is a negative. So tangent is negative here. So that means the only thing we have positive is cosine. So where we see SACT, that is what is positive. There's a couple of acronyms people use. Some people say SAT, other people say ACTS. It's up to you on what acronym that you use. Okay, so what we've learned so far is that quadrant one is our A and B, our cosine and sine is positive at this point. One of the things we do know is there is some symmetry. That means if I look at the point over in quadrant two, the y value is the same, the x value is just going to be negative. Likewise, in quadrant three, it's going to be negative for A, negative for B. Likewise, over here, we are going to have a positive A and a negative B. So let's look at the second quadrant. So some of the things we can look at is our sine theta, which is this part here, is going to be the same as pi minus theta because this here and this here are the same angles. And we know here this goes up. So that means it's going to create the same angle here. And we know S is positive in this area. We know everything else is negative, which is the reason why I've got cosine pi take away theta is going to be equal to negative cosine theta. So these are just rules of symmetry that we've already learned. We know tan pi take away theta is going to be negative tangent because our our angle over in quadrant two is a negative for tangent. Okay, we've got quadrant three here. Again, we're starting at sine and then we're going pi from this line here plus theta. So in this one here, we know our sine will be negative because we've got SACT. So tan's the only one's positive. So pi plus theta will just give us negative sine theta. Likewise, cosine. If we're adding theta onto it, we're going to get negative cosine here because it's in this quadrant. Our x value is negative. Likewise, our tangent. We've got a negative over a negative, so it's going to give us a positive. So if I go pi plus theta, it will give us just tan theta. So be mindful of that. And the same thing applies here. So we need to just really understand our unit circle with our symmetry. Okay, with negative angles, again, we need to be thinking about here, if I've got sine and I go negative theta, that's the same as what is sine theta, and then I put a negative on it. Likewise, tan negative theta is exactly the same as just negative tangent. Let's go through some of these questions. Okay, so I'm going to give us some questions on this where we've got sine theta equals 0.42, cosine x is equal to 0.7, tangent is equal to 0.38, and we're going to apply our understanding. So the first thing, sine pi plus theta. So I go pi plus theta, we are going to be in quadrant three. Quadrant three is SACT, tangent is positive. That's the first thing we need to know. That means our sine will be negative here. So sine pi plus theta equals just negative sine theta. So our sine here is 0.42, so our answer will be negative 0.42. Likewise, sine 2 pi take away theta. Again, I'm starting at 2 pi, I take away theta, so I'm going to be in quadrant 4. Now we know SAC, cosine is the only one that is positive. That means sine will just be our negative theta. So our sine theta is 0.42, so it just tends to be a negative. If I look at cosine pi minus x, same thing. This is x, but if I start with pi and then minus x, I'm in quadrant 2. Quadrant 2 is sine is positive because it's SACT. So if it's sine is positive, cosine will be negative. So this is going to be equal to negative cosine theta, or sorry, negative cosine x, I should have put. That means, what is my cosine? It's 0.7, so it'll be negative 0.7. Then I look at this next question here, and it says if cosine x is equal to negative cosine pi over 4 and pi over 2, so x is greater than pi over 2 and less than pi. So first, this part here tells me that it must be between this part here, so it's in quadrant 2. That's the first thing it tells me. So that means we're dealing with cosine x is going to be equal to cosine pi minus x. Okay, that's the first part. Now, first thing we're going to be thinking about here is we're looking at pi over 4. So that means I'm just going to plug that in. So I've got cosine pi, take away pi over 4. Now I'm just going to change this and simplify it. Pi, take away pi over 4 will turn into 4 pi over 4 minus pi over 4, which is 3 pi over 4. So now it's literally just asking what is our x value right here? And our x value is just going to be 3 pi over 4. Let's have a look at this next question. If cosine x is equal to cosine pi over 3 and x is greater than 3 pi over 2 and less than 2 pi, the first thing I need to be thinking about here is the following. What quadrant am I looking at when it's dealing with 3 pi over 2 and 2 pi? I'm dealing with quadrant 4 over here. Quadrant 4 means I can just go 2 pi, take away that x value. So that's what we're looking at the moment. We're always using it from this x-axis, as you can see with what I'm drawing. So next, we know that we've got pi over 3 here, so I'm just going to rewrite that. Instead of x as 2 pi minus pi over 3. I'm going to simplify this, so that will be over 2 pi over 1, which is 6 pi over 3. I simplify it to 5 pi over 3, so then that x value must be 5 pi over 3.